we're going to flesh out a little more of collision theory and talk about the idea of sterics. So the idea of sterics is the recognition that molecules are three-dimensional objects with shapes. And so when molecules are going to be colliding, they need to collide with the correct orientation. Okay? So if we write a chemical reaction, for example, ammonia, NH3, plus water, H2O, gives you ammonium cation and hydroxide. So you take two molecules, they could react, and they could become two polyatomic ions. Well, when we write that chemical formula, we just would say like, well, we can see that one of these hydrogens, right, it was like two hydrogens here, it's only one hydrogen here, so that hydrogen's going to go over to here and it's going to attach on. So we can count the change, or we can observe what the change of the chemical formulas is. But if we actually look at the molecular shapes of these structures, we can see that it's not just random. It's not just that you're going to lose a hydrogen, but instead that the water molecule is going to have one of its bonds be broken. The bond connecting the hydrogen to, say, the oxygen is going to break. And at the same time, a hydrogen is going to form a bond with a nitrogen atom. Okay, so one bond in one of the molecules, reactant molecules, is going to break, and you need to form a new bond in one of the product molecules. So when these molecules collide, if NH3 and water collide, they need to collide in such a way that that atom can actually transfer, right? It is this one of these hydrogen atoms is going to move to this molecule over here. So when the collision happens, if, say, this ammonia molecule collides such that the nitrogen hits the oxygen, that's not going to drive the chemical reaction. You are not trying to form, you're not going to form a new bond between the nitrogen and oxygen. You could, but that's a different chemical process. And that is not going to be successful for the particular chemical reaction we are interested in. In order for the collision to occur, if you are looking to form a bond between a nitrogen atom and a hydrogen atom, when the collision happens, the molecules need to collide such that those two atoms make contact. If they're going to be joined by a chemical bond in the product, when the two initial reactant molecules collide, those two atoms need to touch. So this is this idea that the molecules not only need to collide, but they need to collide successfully. These sterics have to be maintained. They have to collide in a in an orientation that is conducive to the actual reaction that you care about happening. In this case, forming a new nitrogen-hydrogen bond. On top of that, there's, it's not just that you can collide with anything. If we look at this case, it's NO, so nitroxide reacting with ozone to make NO2 and O2. So we can see if we look at kind of the change, what's going to happen is one of these oxygens is going to go on to the nitrogen, NO molecule. You get NO2, and then you'll only be left with the O2. So if we look at what this would look like, say the ozone molecule looks like this. It's the three oxygens in a row. The bigger blue sphere is the nitrogen. And so we'd imagine the nitrogen is going to form a bond with one of those oxygen atoms. But the thing is, if we think about colliding, if it were to collide with this central oxygen atom, that's not likely to be a successful reaction because it's trying to form a bond with only one oxygen atom. And that is in the middle of this molecule, right? You'd be taking an atom out of the middle of the molecule. Instead, it has to collide in with one of the outside oxygens. So you can think it's not just that the nitrogen needs to form a new bond to the oxygen, but that oxygen atom that was in the O3 molecule needs to be removed from the O3 molecule. So in this case, you would just be breaking this bond right here, removing the oxygen off of the end of the molecule. So there's a lot of requirements when it comes to having these orientations line up just correctly. On top of this, you got to collide. You know, you think about forming new bonds. You have to, which atom would it, you got to collide with the atom that's kind of on the outside. It's got to be the right one. The molecules also have to have the kind of right trajectory to come in. So if you look, we got the two big blue molecules that are colliding with the two red, and basically they're just going to trade partners and become mixed molecules. And so in this case, if they collided just like perfectly head on, they hit each other perfectly, that would lead to a transition, and they'd move. But if, say, they were kind of, in this case, you can see those black arrows are showing that these molecules are kind of spinning around. They're spinning around, and in this case, they just kind of glance off of each other. They just kind of spin off. So not only do the right atoms have to touch each other, but the molecules have to kind of collide head on. They can't hit glancing blows. They can't hit kind of askew or off to the side. They really do need to collide just right. It's really hard for these molecules to collide with the correct orientation. Good thing, when we look at these things, it can kind of show it is, it is a 1 in a billion chance that these molecules are going to collide in the correct orientation. But one of the things we have to remember is that, if you're dealing with like a mole of molecules, you have sextillions of molecules. You have billions of molecules. So that's why we can see reactions happen with a reasonable amount of time, because there's lots of collisions happening. Yes, it is a 1 in a billion, 1 in a trillion chance that the collision will be right, have the correct orientation, but we got a lot of collisions going, so it's going to be okay. It'll happen in the end. And it's just a matter of, again, you increase the number of collisions, you're just making those chances. It's really rare that the collisions will hit with the right orientation. You do enough collisions, though, eventually you'll get a high enough chance. And you'll hit that chance of having the right orientation. Okay, Sterics, cool word. See you in the next video.